Hey everyone, so this video is going to describe a process we can use to identify the graph of an inverse function. Alright, so I'm going to go through three examples where I have a graph. We're going to make a table of that graph. We're going to make the inverse table, and then we're going to graph the inverse table. Okay, so my first example here, I've already plotted a few points, and so I'm going to use that. I'm going to use these points to make my table. So counting by ones, we have 1, 2, 3, 4, 5, 6, 7, -7 up 2. So here is my first point, -7, 2. My next point looks like -3, 1. I then have a point at 1, 0. And another point at 5, -1. So this is just the original graph that I have, and that's how I pulled those points. Okay, so just pulling those points into a table. Now remember, when we make a table for the inverse function, what we're doing is we are flipping our 2 points, our x and our y values. So I'm going to go in a different color here. I'm going to go with red. So instead of the point -7, 2, the inverse function is going to have the point 2, -7. Instead of the point -3, 1, the inverse function will have the point 1, -3. Instead of the point 0, 1, or I'm sorry, instead of the point 1, 0, our inverse function will have the point 0, 1. And instead of the point 5, -1, our function will have the point -1, 5. All right. So now that I have those new points for my inverse table, I'm going to plot those new points. So 2, -7, so 2, 1, 2, 3, 4, 5, 6, 7. Looks like here's my point there. 1, -3. 0, +1. And -1, 1, 2, 3, 4, 5. So here is f inverse of x, all right? And my first graph is the function f of x. So if I'm trying to recognize the inverse graph, what I can do is make a table of the original, then I can make a table of the inverse function, and then I can plot those points. Let's do this 2 more times for us. So now I don't really have points that are perfect. I don't have dots to represent where they are, so now I kind of have to, not really guess, but I just have to look at the graph a little closer. So I see that I have a point here at -3, 2. Looks like I have a y-intercept at 0, 1. Looks like I have an x-intercept at 3, 0. And another point at 6, -1. So I'm going to make a table of those values. So -3, 2, 0, 1, 3, 0, and 6, -1. So those are the points on my original function. I'm going to flip them to get my inverse function. So instead of -3, 2, 2, -3. Instead of 0, 1, 1, 0. Instead of 3, 0, 0, 3. And instead of 6, -1, -1, 6. Now that I have my inverse table, I'm going to go and plot those points. So 2, -3, 1, 0, 0, 3, negative 1, 1, 2, 3, 4, 5, 6. And I'm going to extend that line a little bit just so we can see where it's going to go. So here is my inverse function, and here is my original function. All right. At this point, what I'd like you to do is actually pause the video and try this one yourself before you play it, okay? And then play the video, see if you got the right thing, and then you should be good to go. So I'm going to make my table, all right? Or I'll give you a chance to pause first. So I'm going to make my table. It looks like I have a point here at 0, 1. I have another point here at 1, 4. I have a point here at negative 1, negative 2. And that should be enough points so that I can make a table. So my first point, negative 1, negative 2, 0, 1, 1, 4. So now that I have those points, I can make my inverse table. Instead of negative 1, negative 2, negative 2, negative 1. Instead of 0, 1, 1, 0. Instead of 1, 4, 4, 1. Now that I have my inverse table, I'm going to go ahead and plot those points. Negative 2, negative 1, 1, 0, and 1, 2, 3. 1, 2, 3, 4, 1. So I noticed that how I kind of kept that line going, I noticed that if I were to draw a dotted line, my slope is up 1 over 3, up 1 over 3, up 1 over 3 to get my slope. All right. So those are 3 examples to graph the inverse function. So once you've watched this video, go ahead and try the problems in your review.